And do it himself. Lorenzo, thank you for coming. The floor is yours.
Thank you very much, and thank you for having me here once again. It's always a real honor. Today I'll be talking less about WebRTC and more about QUIC, which is a new exciting way of getting real-time media out. And in fact, that's why I called it, is it an interesting opportunity or wasted time? And we'll see if I have an answer by the end of this presentation. So just a very few quick words about me. I got my PhD at the University of Naples. I'm one of the co-founders of a small company called Meetecho, and I'm the main author of Janus, even though today I'll be talking more about a different project that I'm trying to spearhead that is called imquic. And here there are a few links if you want to get in touch with me. Again, I won't bother you too much with this. I mean, as Meetecho, we do the usual stuff that a small company does. So we do a lot of work with consulting and support related to open source software. We work a lot with standards, open source, which is why we love SIP, we love WebRTC, and we've been doing this for close to 20 years if we count the academic years as well. But again, today we are not going to talk about a lot about WebRTC. We are going to touch it, but mostly I wanted to focus a bit more on QUIC itself. And even though I don't have much time, I wanted to give a very quick introduction on what QUIC is in general, because not everybody may be familiar with it. And the idea with QUIC was that at the time they wanted to basically improve about the existing HTTP protocol because it had several issues related, for instance, to head-of-line blocking and other problems that are strictly related to the transport protocol that HTTP uses, which is TCP. And they basically tried to come up with a new fancy protocol that could basically look a bit like TCP on steroids, if you will, but actually working on top of UDP rather than being its own protocol, which means that QUIC, you will basically always find QUIC as a user space protocol rather than a kernel-based protocol itself. And being based on UDP gives us some interesting properties. As you'll see, even though there are a few interesting properties about QUIC itself, like for instance, the fact that it is always encrypted by design, which means that we don't have a decoupling as we do with TCP, where we first do the TCP handshake, and then after that we do a TLS handshake to secure that. Basically, everything with QUIC is always encrypted, and since everything is, the encryption is part of the QUIC protocol itself, it means that even just that should give us basically a faster connection time when compared to TLS over TCP, because we're basically doing two things at once when we connect. And it has a few interesting properties. I mean, TCP-like congestion control, loss recovery, all the things that you expect from a reliable protocol of source, but also much better connection migration, because again, we are building on top of something that doesn't have a connection at all, unlike TCP, which means that migrating a connection is much easier because there are a lot of abstractions taking place. Even though from an application perspective, and again, I put application on there because it's true that it started for HTTP3, but it's actually a generic protocol that you can use for whatever you want, is that it also has something that is called stream multiplexing, which is one of the biggest advantages that it has on top of over plain TCP, because TCP basically has a single stream over which we send everything, which means that if we are sending 3 different messages related to 3 different things, and maybe packet 2 is slow to go through, then with TCP we have to wait for packet 2 to go through before we can get everything else. With QUIC itself, instead, we can basically have the so-called stream multiplexing. So we can have multiple streams that actually are traveling across the same QUIC connection, and each of these streams acts like a mini TCP if you want, but don't quote me on that because I'm sure that the QUIC people wouldn't love it. But basically the idea is that each stream works a bit like TCP, meaning that each stream has ordering as part of it, has reliability as part of it, but each stream is independent of each other. So if 2 is slow, then the other streams are not affected. So they can go in parallel, which is great for going beyond the head-of-line blocking issue that TCP has in itself. And it also gives us interesting opportunities because then we can prioritize these streams, or we can get rid of some streams in case we don't need them anymore, which gives us a lot of flexibility in terms of what we want to send and when for different reasons. And each of these streams can also be independently flow controlled, which is also a nice property that it has, even though, of course, you have flow control as part of the whole connection. And the thing about QUIC is that in general, when you have a transport protocol or any kind of specification that comes out of the ITF, you typically have one big document to read and you're done. Like for instance, with SIP, we all know 3261 is the document that we have to read to learn everything. With QUIC, it's a bit more complex than that because you have basically 4 different documents that you have to read just for the basic QUIC specification, which is a lot, but there is a reasoning behind that. And that becomes even more than that whenever you want to go a bit beyond that. So if you want HTTP3, that's another thing, but HTTP3 has a mandatory compression extension code that is called QPAC, which is another document instead. If you want to use datagram, which is basically a way to use QUIC as close as possible to raw UDP, that's another document as well, and web transport and so on and so forth. But even though it seems complex, I mean, there are a lot of implementations out there. Basically, everybody and their dog has a QUIC stack now. And it's all available in different programming languages, which means that everybody who is interested in getting into it from a programming perspective has access to that. I decided to self-punish myself, and so I tried to implement my own stack instead. And so I basically learned a lot from those documents, but also from these 2 blog posts over here, which I recommend to read in case you want to learn more, because it gives a very practical approach about how QUIC works, because there are some things that you need to go through. And another interesting property of QUIC is that with web transport, which is an extension of HTTP3, you can basically get the equivalent of basically what WebSockets are for plain HTTP. So it's basically a way to get a standardized API from the browser to basically do QUIC, because once you have done with the establishment of web transport using HTTP3, you can basically just exchange messages over on top of QUIC using a very thin layer and from a browser, which means that it's very interesting to basically have access to QUIC from a browser to do cool things, which, as we'll see, is actually quite important. And we have access to datagram as well, which is also very interesting in case we want really low latency for any reason. And this is just a very quick overview of how it looks when compared, for instance, because you can use web transport over TCP as well, but of course it doesn't make much sense. It makes more sense on top of QUIC because with TCP we have WebSockets already. Which brings us to the main question. Can we use indeed QUIC for real-time media as well? Because of course HTTP3 is great, but that's not real-time media. That's basically serving content in a more static way. And we can make a quick comparison with WebRTC that we basically all know about. So we know that WebRTC is based on UDP as VoIP or IP developments, which WebRTC borrows are based upon, which gives us the ultra-low latency that we need for conversational use cases. And even though WebRTC is peer-to-peer by design, in practice, we almost always use a client server anyway. So we have a WebRTC server that we use to communicate with from our browser or mobile endpoint. We do have optional support for retransmissions and congestion control if you want, and bandwidth estimation as part of that. And of course, it's natively supported in browsers, which was the big winning point of WebRTC in the first place. And when we look at QUIC, we can draw some sort of a comparison with that, because even though it has TCP-like properties, for instance, for the different streams, it is also based on UDP, which means that in theory, at least, it should be able to give us lower latency than TCP for sure. Sorry. It optionally also supports the frame datagram that is basically as close as you can get to raw UDP. It is always client-server, so it's never peer-to-peer, always client-server. But as we said, this is how we use WebRTC anyway. And of course, since it mimics, or let's say borrows some properties from TCP, it supports retransmissions, congestion control. It has the multiple streams functionality that I mentioned that is really useful. And if we use it with web transport, we can also use it in a browser directly, which means that if we also use stuff like modern stuff like web codecs and WebAssembly, we can get a media stack in a browser that we can use with QUIC if we wanted. Which means that when we start having a look, the ITF started to have a look at what can we do with real-time media, the first option that came to mind was let's just try and put RTP on top of QUIC, which is a document that is going on in the ITF right now. And most of the document actually covers the overlap that happens. So the things that you can avoid doing on top of QUIC because you don't need it. For instance, you don't need SRTP because QUIC is always encrypted, unless you want end-to-end encryption for any reason. Most of the feedback that RTCP gives you, QUIC already gives you out of the box, round-trip time, to give a very simple example. You have congestion control and so access to bandwidth estimation functionality as well. What you do need is basically a way to frame RTP packets, because especially when you use streams, you are acting with a stream-based delivery, which means that in that case you do need to have a way of saying this packet is this long, especially if you're using the same stream for multiple packets. And to do that, basically, RTP Over QUIC introduces a new component that is called the flow identifier. So basically, you tag packets and you say this packet is related to this flow ID. And so, for instance, a very simple example could be all packets with flow ID 0 are my audio packets, all packets with flow ID 1 are my video packets. But the kind of mapping and how you do it is entirely up to you and how you negotiate stuff, but that's really the idea. What's most interesting is that I can use both datagrams or streams to send data. And when I use streams, since a stream, I can create as many streams as I want, and I can pack as many packets on top of a stream as I want. Basically, the real trade-off is how many packets do I put in a single stream, because I could spawn a single stream each RTP packet that I have, and that's an option. Or I could put more than one packet on the same stream, and in that case, I just need to specify the flow identifier once, because each packet that follows will be related to that flow. What you really don't want to do is use a single stream for the whole conversation, because in that case, it becomes like TCP. So you encounter the head-of-line blocking as well, but a simple approach could be, which is what most people are doing, for instance, for video, I start each stream with a keyframe, and everything that follows is a difference from that keyframe. Anytime I receive a new keyframe, I start a new stream so that everything is pretty much isolated and works better. Which then brings us to the next question. What can we use RTP Over QUIC for then? And the idea is that, of course, the main thing that could come to mind is why not SIP itself? I mean, why not use SIP over QUIC itself? And that's something that somebody thought about as well, and there is an expired draft that talks about that, to basically try and learn from everything that has been applied to HTTP3 and apply it to SIP as well, in terms of better pipelining, better compression especially, because a lot of the headers in SIP are repeated over and over and over, and there is much better compression that you can achieve, which is something that they managed to do with HTTP3. And I actually don't know, to be honest, if that draft is going anywhere or what will be the next step, but somebody is definitely think about it. And I think it could be a good idea because there's a lot that QUIC can bring to the table also in terms of security, connection migration, as I mentioned, could be a very important add-on. Of course, we will need some way to negotiate those RTP over QUIC sessions on top of SDP, for instance, to negotiate what those flow identifiers mean. I think that even without all of that, maybe media trunking could be a good idea, just because of the fact that we can use flow identifiers to pack a lot of RTP sessions on top of the same QUIC connection makes media trunking possibly a good idea, because then we can take advantage of the congestion control, the flow control that QUIC has to manage all that, which was basically the main idea behind RIP, if you remember it. So that proposal that was about some time ago. They wanted to use HTTP semantics rather than RTP, but basically the concept is the same, trying to leverage the benefits that QUIC can bring to the table. But there's also the idea that since this is RTP, it's simple to bridge to WebRTC, which is also RTP based. And so this could provide a very easy way to basically start and having WebRTC and QUIC work together by basically talking the same language, basically. And I'll show a quick example of that in a second. Basically, the main thing that we need to worry about is how to associate and map these flow identifiers to an M line in the SDP, basically. All that said, though, RTP over QUIC is not really the main effort for real-time media on top of QUIC, because there's another effort that is gaining much more attention, which is completely different, though, which is called Media Over QUIC. And they're basically trying to address a different thing. So the generic distribution of media that has configurable latency, so that if I'm watching a football match, I can watch it in real time, or go back 20 minutes and go back to real time using the same connection, basically. So of great interest to CDNs, great interest to conference providers, great interest to real-time service providers, but it's also much closer to a traditional SFU from the WebRTC aspect. So this is definitely not something that I can see mapping easily or at all to SIP as a signaling protocol, because all of those streams are monodirectional. There is a publisher, there is a subscriber. It's really quite different, but it's basically the main direction that everybody is going through. So just so that you are aware of it. And that said, though, this brings me to the last part of the presentation, and I'll try to be quick because I may be short on time. Basically, I created this library to try and play with all of this. So I wanted to write my own QUIC stack, but I also wanted to play a bit with both RTP Over QUIC and Media Over QUIC. And if you're curious about the name, it's a double pun, actually, because of course it spells like I am quick, which is always nice. But it's also, you can also read it as Iron Maiden QUIC, because basically this is the slide that I always showed every time that I said I really want to learn about QUIC. They had a song that is called Be Quick or Be Dead, so I had to do that. And some may say that I lost a great opportunity for a much cooler name. But I really didn't want Nestlé's lawyers behind me, so let's say the other name was safer, let's say, for sure. And just to give you a very quick overview, because I don't want to bother you too much with it, it's an open source library, and these are a few links if you want to learn more about it. There's also a detailed blog where I introduce it in more detail. It's generic, meaning that you can use it for a generic library to build something on top of either raw QUIC or web transport or both. But it also has integrated support for RTP Over QUIC and Media Over QUIC to play a bit more proactively with those, using higher level APIs to interact with those. So that if you use the RTP Over QUIC API, it masks a lot of the details about QUIC itself. So you don't need to know much about QUIC, you just need to know that there are RTP packets going back and forth. And of course, it's definitely not ready for production at all. It's something that I'm playing with at the moment. It needs a lot of love, especially the QUIC stack part, because it's a complex protocol, but it's given me a lot of fun and opportunity to experiment with these protocols in a sandbox environment, let's say. And RTP Over QUIC is indeed what I wanted to prototype first, because it was the easiest one to start from. Basically, I wrote the multiplexing and the multiplexing functionality as part of the library that would be used on top of the QUIC streams and datagrams. And then I created a couple of demo applications, like an RTP Over QUIC server and an RTP Over QUIC client, where one could send RTP packets over QUIC to the others, and stuff would happen, basically. And I also wrote a basic integration in a Janus QUIC plugin that, time permitting, I will show you in like 10 seconds to show you how it works. And I also tested this, of course, with other implementations as part of the IETF hackathon. I added some Qlog support for better debugging and so on. But basically, if you just use the command line applications, they look like this, so a bit boring, if you will. This is a client that gets RTP packets from something else, like a GStreamer pipeline, and whatever it receives, it sends here. And of course, tagging the packets with the flow ID that we want to use. And this is how it looks like when I integrated this in Janus, though, where I have Janus acting as an RTP Over QUIC server, so that if I use my RTP Over QUIC client, I can send RTP packets via QUIC to Janus, and then Janus will send them via WebRTC to a browser. And this is an example. Or I could do the other way around. So publish RTP packets via WebRTC and then send them via RTP Over QUIC to an existing RTP Over QUIC server. Or do what I was saying before. So basically basic trunking where I have WebRTC end-to-end, but the two Janus instances are actually connected via RTP Over QUIC, because this is an RTP Over QUIC client, this is an RTP Over QUIC server, and then basically the end users are seeing WebRTC, but the actual backend is actually RTP Over QUIC, which gives you an idea of how the trunking may work. And just to give you a very quick idea, I can show this in real time. Like I have this demo that I can start over here. I can start a client. I can start a client, and I can start GStreamer, and then something magically happens. That is basically the Iron Maiden song that I was mentioning before. So nothing fancy, but this is basically receiving RTP via RTP Over QUIC. And now, last slide, because I'm done. Basically, what's next is, of course, figuring out if this all makes sense. And as I was saying before, it's really a matter of figuring out what will happen with respect to SIP over QUIC, and what will happen to RTP Over QUIC as well as part of that. Considering that, again, Media Over QUIC is the main topic of it all. I'm spending a lot of time, of course, on imquic itself to try and improve it as much as possible, but for that I will need some feedback also from other users. And of course I want to release the Janus integration as well. And again, this was also an opportunity to introduce this library to everybody. So in case you're interested in this and want to play a bit with it, so feel free to do that, feel free to give me some feedback. And I hope I'm more or less on time, even though I may have rushed things a bit. So thank you.
Thank you, Lorenzo. No worries. So we'll have a question, but first, Nacho, you can come in front and switch the microphone. Lorenzo, you'll answer on this one. So we speed up a bit setup. We can take it later. Okay, so there were one question here.
As you dig into it, doesn't seem to you that QUIC a little bit over-engineered for the media because of for the RTP, sorry, because of RTP with its extensions already existing for the WebRTC and standards covers almost everything, and QUIC itself brings the same functionality like one-switch estimation, then re-receiving packets, so error correction things, and adds this overhead with the layer. So yeah, it should be better connectivity, but then slower or let's say a little bit more complicated scenarios of using RTP within the QUIC. How do you think?
Yeah, no, I think that the main advantage of using RTP directly is basically because it makes it much easier to interact with everything that is existing. Because, for instance, one of the things that our Media Over QUIC has with respect to RTP Over QUIC is that if I have to send a video frame, with RTP I typically chop it up in multiple packets because I assume I have to fit into a limit that is the MTU. With QUIC I really don't need that because I can spawn a stream that can be as long as I want, and I could send the whole video frame on top of that, and then QUIC will chop it up in multiple frames according as how it is needed. So you really only use RTP if you want an easier integration with existing deployments. So for instance, a media trunking solution or interaction with WebRTC or whatever. But for something new, it doesn't bring anything new to the table except for the fact that it is well known, it is easy to address a specific payload type or to say this is that, and then send it out, because otherwise there is a lot of stuff that overlaps, as I mentioned in the draft. So they say that there is a lot of things that you don't really need, so you can forget about most of the stuff about RTCP. You just send RTP packets and you're done. So it's definitely not the best option. It's just the first option that came to mind in terms of how can we actually do this. And the answer is that you can indeed use it because especially when you use streams in a certain way, you can do stream prioritization, you can just drop some streams entirely, which means that you can keep up with the delivery, which is something that you cannot do with RTP over TCP. Just because you can have multiple streams, and so if you need to keep up and there is congestion and whatever, you can adapt much more efficiently than TCP could do instead.
Okay, so looks like a lot to explain here. So for you, maybe you catch up with during the dinner time social.